Okay, class, we're gonna learn next chapter. So chapter 12. This is going to be the concept of limits and continuity in two dimensions. So first of all, let me review you what you're gonna learn first. So let's suppose that we have a function fx equal to x cubed minus 2x squared minus x plus 2. In one dimension, you can draw a graph of this thing. If you want to, you can use a calculator or you can use Google to plot the graph here. Or you can just use the calculus that you learn in calculus 1 to graph this one. What you learn in cal 1, you learn how to compute limit, right? So you know how to define limit fx where x go to a. So in order to compute that, you're gonna do limit x go to a of x cubed minus 2x squared minus x plus 2. And for example, if I want limit x go to a, so I can plug in a. So a cubed minus 2a squared minus a plus 2. So this is going to be your answer for limit, right? This is limit x go to a of fx. You also learn how to differentiate. So f prime x. So this is how you diff. So you're gonna differentiate and then you get 3x squared minus 4x minus 1. This is how you differentiate. You also learn how to integrate in cal 1. Integrate fx dx. Let's say start from 0 to 1. So what you're gonna do, you're gonna integrate this function. This. And then you integrate it, so you're gonna get x to the 4th power over 4 minus 2x cubed over 3 minus x squared over 2 plus 2x and then plus c. If you don't need the boundary, if you don't put the boundary, so you're gonna get just plus c here. So what you're gonna learn after this point, you're gonna learn how to compute limit. You're gonna learn how to compute differentiation, and then you're gonna learn how to integrate in two dimensions. So that is what you're gonna learn. So one more time, this is in one dimension, but what we're gonna introduce you in a minute, it's gonna be fxy. This is going to be a function of two variables. So you're gonna learn how to find limit of fxy. So in order to do two dimensions, so you're gonna do xy going to ab. So it is not the same thing as before because you're gonna have the point xy going to the point ab. And when you differentiate fxy here, you're gonna have to differentiate with respect to x, and then you're gonna have to differentiate with respect to y. You're gonna have two ways to do it. Integrate as well, you're gonna have two ways to do it. So chapter 12 gonna deal with how to find the limit and differentiation. Chapter 13, you're gonna learn how to do the integration into dimensions. So, and that's all the content you need for the final. So you need to learn how to diff and integrate into dimensions. Yes, integrate. It's gonna be this one. Integrate fxy and then dx dy, or integrate fxy dy dx. So what we're gonna do is we're gonna try to simplify everything and go back to one dimension. So you can use the formula you learned in cal 1. So you're gonna see that at the end for differentiation and integration, you're gonna come back and learn how to use the formula in calculus 1 to help you to calculate this thing. Alright, so first of all, let's start by looking at the function of two variables. So this thing gonna be the one that you actually have the domain to be two dimension here, and then you send any point in the domain to the real number. So basically when you plug in the value, you're gonna plug in x and y together at the same time. So once you plug in x and y together at the same time, it's gonna go back to one dimension. The range gonna be just in one dimension. Usually we use the notation c equal to fxy here to represent the function in two variables. So keep in mind that your x and y gonna be independent variable, and then your c gonna be dependent variable. Okay, so take a look at example first. So example 1, find and sketch the domain of the following functions and compute f11. So part A, I have fxy equal to square root 6 minus x square minus y square. So first of all, we're gonna compute f11. So everyone, we're gonna compute f x equal to 1, y equal to 1. So when you compute, you're gonna plug in 6 minus 1 square minus 1 square. So you plug in x equal to 1, plug in y equal to 1. So you get square root 4, and that is 2. So f11 equal to 2, okay? And then now to sketch the domain. So you're gonna find the domain first. So the domain gonna be any point x, y such that. So because you have square root here, you know that the thing inside square root must be non-negative, right? So it's 6 minus x square minus y square bigger than or equal to 0. And this is actually x square plus y square less than or equal to 6. Can you follow that? This is actually the domain. And then you need to sketch the graph of x square minus y plus y square less than or equal to 6. What is the graph of this one? So it's gonna be the circle, which radius square root 6. Square root 6 gonna be your radius, right? Because this is your r square, so equal to 6. So the radius is equal to just square root 6. And because you want something inside the circle because it's less than or equal to, so you can shade the thing inside here. So this is actually the sketch of the domain. So it means that you can only plug in the thing inside here. So it can be calculated. Otherwise, it's gonna be undefined because it's gonna be outside the domain of x and y here. So the thing that we're gonna test you a lot about the domain is that under square root sign, you have something greater than or equal to 0. When you see a over b, the thing on the denominator cannot be 0. And also logarithm of any function, after logarithm it must be positive. This is the thing that you keep in mind that you use a lot. So after log must be positive. This is the first one. So the second one, under square root sign must be non-negative, right? Must be greater than or equal to 0. And then the number 3 is that the denominator cannot be 0. Denominator cannot be 0. So this is the one that you're gonna see a lot in the exercise in the book or even on the exam. This is going to be the 3 point that we ask a lot. So after log must be positive, under square root sign must be greater than or equal to 0, and denominator cannot be 0. So we're gonna do question 2 here. So if you know yourself that you are not good at graphing, so it's gonna be the time that you need to be expert on it, because when you integrate it, you need to graph a lot, because you need to graph the region that you integrate with respect to. So next one, we're gonna do fxy equal to log x square minus y plus 1 here. So this means you can plug in f11 first. This is going to be log 1 square minus 1 plus 1. And this is log 1. This is actually 0, right? E to the 0 is 1. E to the 0 is 1. So log 1 is equal to 0. And this time when you compute the domain, so the domain gonna be all possible x, y such that x squared minus y plus 1 greater than 0. What is this one? So you can just simplify first. So you're gonna have xy y less than x squared plus 1. Okay, like y less than x squared plus 1. So you need to graph y equal to you need to graph y equal to x squared plus 1. So the best way to graph this one, you graph y equal to x squared first. So it's actually this one, y equal to x squared, right? Yep. And because you plus 1 here, it means you shift by 1 unit, right? So you're gonna shift this thing by 1 unit. So it means that when x equal to 0, y gonna be 1 now. So remember this one here. So you're gonna shift up 1 unit. So it's gonna go up 1 unit. Shift. Basically, you're gonna start from the parabola, the regular parabola here, and then you move everything up 1 unit. This is what you do by plus 1 here. And then you're gonna get parabola here, but because this is less than sign, so you are not going to include the thing here. So we're gonna do the dash line. So it's gonna be, it means we do not include the line. So this is a line y equal to x squared plus 1. Which side do you want? This one or this one? Which side do you want? So you need less than, right? So it's mean, well, the easiest way to figure out which side do you want, A or B, you can just plug in any point you want and then see which side do you want. So let's suppose that I plug in 0, 0 here. So 0 less than 0 squared plus 1. So this is true, which means the 0, 0 is on the side that you want. So it's actually you need this one. This is how to sketch the domain, and this is the domain you want. Right? Anything here in this area. Make sense? So this is actually 0, 1. This is 0, 0 if you want to plot over there.
So in order to able to do this one, I should remember all of the coding section, right?
The thing that you're gonna use a lot is parabola and circle. This is all you need. But sometimes you see hyperbola, but it is not common to see something else other than parabola and circle. So I would say that you need to know how to graph parabola and circle. Anything else, so it's gonna be the line you need to know for sure, parabola you need to know for sure, circle you need to know for sure, but some other than the line, parabola and circle, you don't need to know it. So the exam gonna be parabola. Oh, when I say parabola, it means square root function is parabola as well, because parabola is y equal to x squared. But when you see y equal to square root x, it's just this one, right? Y equal to square root x is this one. It's the same thing with x squared equal to y. So, but you just have this one. So this is actually the same function, just different axis. All right. So this is how to sketch the domain of the function of two variables. Okay, so we already talked about this one. So when you have fxy, we're gonna need to learn how to define limit, how to find differentiation, and how to find integration. This is what we're gonna learn. So this is actually chapter 12. This is actually chapter 13. And this is all you need for the final. This is gonna be just limit, diff, and integrate into dimensions. So if you learn how to find limit, you learn how to diff, and you learn how to integrate, you should be able to do it in 5 weeks.
5 weeks?
Before the final.
Bless me.
Here, you learn it in 5 weeks, and then you're gonna have the exam at the first week of May, right? Hmm? 5 to 6 weeks, I cannot remember. It's just only, yeah, that chart.
midterm ยังไม่หาย final ไม่เข้ามา
Well, because after final you only have 7 weeks, but 1 week is Songkran, so you have 6 weeks left.
including สงกรานต์ as well.
Okay, so let's see. When you graph the function in 2 dimensions, it's gonna be the curve here. This is the curve that you graph in 2 dimensions. Basically, you're not going to do it by hand. Usually you do it by using computer. But keep in mind that when you graph it, it's gonna be surface. Because in 1 dimension, when you graph fx equal to x squared, so it's gonna be, because this is in 1 dimension, right?
Yeah.
So you have to graph by using the axis x and y. So you can see, oh, this is the graph on the plane. But when you have 2 variables x and y, when you graph it, you need another axis. So it's gonna be x, y, and z here in 3 dimensions. So usually we're gonna use computer to graph it in real life, but sometimes you can graph it by hand. So the thing that you're gonna graph it by hand, we're gonna learn in few minutes how to graph it by hand. But usually you use computer. The thing is that when you graph the function, it is not easy like in 1 dimension. Because in 1 dimension, if I ask you to graph fx equal to x squared, even you don't know what it is, if you plot enough points, you're gonna get the graph, right? So if you don't know what is x squared, you can try to plot, okay, I'm gonna plot x equal to 1, y equal to 1, x equal to 2, y equal to 4, x equal to negative 2, y equal to 4, x equal to 0, 0, x equal to negative 1. It's gonna be y to be 1. For example, if you plot enough point, eventually you're gonna get the graph. But for the surface in 2 dimension, it's gonna be different. Even you plot a lot, you don't see the picture. So let's see how to graph it. And this is, you know, you can see that here. Lot of complicated functions that you can graph it by using computer. So let's see how to plot it by hand. So everyone, let's find the domain and range of this one and sketch the graph of fxy. So we have fxy equal to x squared plus y squared. So the domain gonna be any point xy such that there's no condition, right? It can be anything, so the domain is like real number. And the range, this is going to be x squared plus y squared, so the range is going to be the positive thing. So it's gonna be 0 to infinity, so it can be greater than or equal to 0, because x squared plus y squared always greater than 0. How do you plot this thing in 3 dimensions? So y, c gonna be on the top one, x gonna be the one that point at you, y gonna be the one here. And then now how do you plot it? So you're gonna start by, of course, if you're trying to plot so many points in there, it will not work. So some people are gonna say, Ajahn, can we set x equal to 1, y equal to 1, and then this is actually c equal to x squared plus y squared. If you have x equal to 1, y equal to 1, c equal to 2, and then you plot 1, 1, 2, and then you plot another one, plot another one, plot another one, plot another one, you will not see the picture easily. So the way that we're gonna do is we're gonna just fix the value of c. So if I fix the value of c to be c equal to 4, for example, if I fix c equal to 4, so what you have left, it's gonna be 4 equal to x squared plus y squared. This is the circle, right? Circle radius equal to 2. So it means that when you fix c equal to 2, equal to 4 here at the c equal to 4 level. So you can think of this one as you have a plane here at c equal to 4 here. You have a plane here on the level c equal to 4, and then you graph the circle on that plane. So you're gonna have something like this. This is the circle on the plane. Make sense? With radius 2. This is the circle on the plane. And also if you have c equal to 2, for example, so you're gonna have 2 equal to x squared plus y squared. This is going to be circle radius square root 2. So it's actually when you have c equal to 2 here, so you plot it, so you're gonna have circle with small radius. And then when c equal to 1, so you're gonna have 1 equal to x squared plus y squared. And then this is circle radius equal to 1. So it's gonna be little circle here. And then if you keep going, you can imagine that it's gonna just, at the end, it's gonna just combine it, and then you get something like a cup here. Make sense? Because every time when you do c equal to k, where k greater than 0, you're gonna get k equal to x squared plus y squared. Anyway, you're gonna get circle with radius square root k. So it's gonna be just something that you keep getting the same thing, and if you keep doing it for all value of c here, so you're gonna get the something like a cup here. So this is the graph of c equal to x squared plus y squared. Technically we call this thing paraboloid. It's in 3 dimensions, so we call the picture like a cup here paraboloid. So you can see that even the easy function like c equal to x squared plus y squared, it is called it gives you the graph here. So complicated function gonna give you more complicated graph. For example, here, if you plot sine x sine y, oh my god, you're gonna get this curve here, which is super hard to draw it by hand. Okay, so because of this graph, so you can graph another graph in the same way, but I'm gonna just show you some graph that is super important in the future. Maybe if you see it. Oh, example 3, it's like some important graph. You done with this slide? Good. So some important graph is like, for example, if you see c equal to square root x squared plus y squared. If you put square root on x squared plus y squared, the graph gonna be a cone. This is the cone one. C, y, x. If you do the same thing, you're gonna get the cone. If you take square root, it's gonna be the cone. If you have c equal to square root constant minus x squared minus y squared, this is going to give you a half sphere. C, y, x. So it's gonna be sphere here with some radius. Half sphere here. It's gonna be that thing. It's gonna be the half sphere in 3 dimensions. This is the graph c equal to constant minus x squared plus y, c equal to square root constant minus x squared minus y squared. This is c equal to square root x squared plus y squared. Technically, if you want the full sphere, if you want the full one, so you're gonna have x squared plus y squared plus c squared equal to 1. equal to some constant, this is gonna give you the entire ball in R3. It's gonna be that equation. The way that we graph functions into dimensions here, people gonna learn it a lot in calculus 3, but I don't think that you're gonna take calculus 3, so you don't have to go further than that. But you can imagine that if you see the curve in real life, that you want to use the sphere, the cone, or the paraboloid, so you can go back and put the equation on it by using calculus here. Another one is the plane. So another one is a plane is ax plus by plus cx plus cc equal to some constant 0. This is gonna give you a plane in R3. Something like here, x, y, c, and then you're gonna have a plane in R3. This is a plane in R3. That one is a cone in R3. This is the sphere in R3, and this is the full circle, like full sphere in R3. It is fun to learn the graph in 3 dimensions if you have a lot of imagination about 3 dimensions, but it's actually, usually people are gonna have a hard time to learn it because it requires so many imagination, because you need 3 dimensions, and sometimes it is super hard to draw the 3 dimension in the in the paper, because it seems impossible to do it, but it's actually you can do it. Yeah, but of course we're gonna have Google and MATLAB, as you said, Wolfram Alpha, everything that you can just plug in and ask the computer to graph it. But some function that is easy enough, you can just graph it by hand. For example, if you see, you're done with this slide. So some function that you see, suppose you have x squared plus y squared equal to 1. In R2, this is going to be just a circle, right? Y, x, this is only just a circle. X squared plus y squared equal to 1. But in R3, you remember, you're gonna have 3 dimensions, so it's gonna be c, it's gonna be y, gonna be x, and then now when you say x squared plus y squared equal to 1, it means x squared plus y squared equal to 1. C can be anything. C can be anything because you have no condition on C. So when you draw it, so it's gonna be x squared plus y squared equal to 1. And C can be anything, so you're gonna get the cylinder with no lid here, right? Because you have circle x squared plus y squared equal to 1, and C can be anything. So this is actually the cylinder radius 1 with no top and bottom, right? It's gonna be the cylinder here. So the graph in R3 is actually complicated because you need 1 more dimension for the variable C. No, we are not going to test you on graphing, but just show you how to graph in R3. This is okay. So because of the complicated things about R3 here, so you're gonna see in a minute that limits and continuity is actually complicated as well because of that. Alright, so we're gonna take a look at the first concept, limits. So we should go to the technique how to compute limits today. Alright, so This is the notation for limits in 2 dimensions. So you have fxy here. You take limit xy go to ab, and if it is equal to L, then this is a notation, same thing as in 1 dimension. And the thing that you can do for computing limit is limit of constant, you still get constant. If you see limit of x, you can plug in x equal to a, you get limit equal to a. Here you can plug in b, so you're gonna get b to y, you plug in b to y. And the theory, the limit theorems, you can use it because if you have limit f equal to L, limit g equal to m, addition of f and g and take limit, you're gonna get L plus m. Limit of f minus g, you're gonna get L minus m. You can pull out constant, you can do the product of limit equal to the limit of product and also the division as well, and then you take the n power, so you get the same thing. So the theory that you learn in Cal 1 still work when you compute limit. So let's try to do example here to show you how to do it. So if you see something like limit 10xy minus 2y square over x square plus y square, the thing that you can do here is you can plug in 1 and negative 1 into the function and compute limit. So it's gonna be 10 times 1 times negative 1 plus 2 times negative 1 square over 1 square plus negative 1 square, and then you get minus 10 and then minus 2 and then over 2. This is actually minus 12 over 2 equal to minus 6. This go back to the limit part when you are, when you were a good student or like when you were a good student in calculus, you said, oh, I can do limits, but when it's come to differentiation and integration, you feel like calculus is getting harder. But when compute limit, you can just plug in that one and then you get negative 6. As before, if you plug in and then you get 0 over 0. So if you get some real number L, as in calculus 1, if you get the real number L as your answer, then you are done because the answer is that number. Okay. Sometimes you're gonna get 0 over 0. So when you get 0 over 0, you need to do the factoring or conjugate as in calculus 1. But we don't have the L'Hopital rule here because in 2 dimensions you cannot use the L'Hopital rule. L'Hopital rule. You cannot do it here because when you have the function of 2 variables, you don't know what variable you're gonna differentiate with respect to, right? There's no theory about the L'Hopital rule in 2 dimensions. So when you see 0 over 0, I would suggest you to do factoring or conjugate. This is the 2 ways that you can do. But if you are lucky enough, you could get real number L. You are done. Like this question, you're lucky enough to get negative 6, and that will be your answer. That's it. So for part B, this is the example that you're gonna see something a little bit odd. So when you plug in 2 and 2 inside the function, so you're gonna get 2 square minus 4 over 2 times 2 minus 2 times 2. This is actually 0 over 0. So you stuck here because this is actually 0 over 0. You cannot compute the limit. So you need to do factoring or conjugate. But this question, limit x, y, go to 2. So on the top part, you can factor to be y minus 2 and y plus 2. Right? On the bottom part, if you pull out one x, you're gonna get y minus 2 here. And then this gonna cancel out, y minus 2. So this is no longer 0 over 0. And then you're gonna plug in 2 plus 2 over 2. This is 4 over 2. It's actually 2. Make sense? This is actually how you manipulate the question with limits 0 over 0. So the technique that you learn in Cal 1, factoring and conjugate, you still can use it in 2 dimensions. Alright, so we already did factoring 1 question here. So the next question gonna be conjugate. Let's review how to do conjugate. So this is the review how to do the factoring. So you factor and cancel, and then you get that one. The next one gonna be the review of using the conjugate. So here, if you want to evaluate limit xy going to 4, 5, square root x plus y minus 3, x, on the bottom part you have x plus y minus 9. So you can, again one more time, you can use the conjugate because you see square root here. So you learn how to use the conjugate here. So it's gonna be limit square root x plus y square root x plus y minus 3 over x plus y minus 9, and then you multiply square root x plus y plus 3. So you just multiply its conjugate. So you hope that once you multiply, it's gonna get better. X, y going to 4, 5. So before you use the conjugate, you can try plug in 4 and 5 here. So you're gonna see that it's actually 0 over 0. Because this is 9, take square root, and then you minus 3, it's 0. And then this is 4 plus 5 minus 9, this is actually 0 as well. Once you do that one, so you can simplify a little bit. So you simplify to get x plus y, and then minus 9, and then over x plus y minus 9 times square root x plus y plus 3. Okay, and then now you can see that the first term cancel out. So you're gonna have only 1 over square root 4 plus 5 plus 3. So the answer is 1 over 6. This is how you compute limit by using the conjugate. So you multiply conjugate here. Right. So 0 over 0 conjugate or factoring. This is the technique that always can use it. Conjugate and factoring.
I have 2 questions.
Go ahead.
First one is that if it's possible that it can be infinity over infinity.
You can, yeah, you can have infinity over infinity, but the thing is, if you see infinity over infinity, you have to simplify and cancel.
So use these 2 methods, right?
Mm-hmm.
Are there any like squeeze theorem as well?
Yeah, we're gonna have squeezing theorem, but not now. Like we're gonna have squeezing theorem soon.
Okay.
Okay, so factoring and conjugate seems to be super simple and easy for you because you already learned in calculus 1. Let's see what are the differences compared to one variable case. So why is so hard in 2 dimensions? So think about when you learn calculus 1 here. When you learn calculus 1, you have limit from the left and limit from the right. This is the point A. When you want to compute limit x go to A, fx, you have limit from the left and limit from the right, right? So you know that limit from the left gonna be x go to A from the left, and the next one gonna be limit fx, x go to A from the right. If they are equal to each other, you're gonna conclude that the limit exists and equal to L as well. right? Everyone remember when you learn Cal 1, you have the left hand limit. And then you have the right hand limit. And if they are equal to each other, you're gonna conclude that the limit exists and equal to L. This is in one variable case. In two dimension, what is different? The difference is if you have the point A, B, you can have so many lines that gonna go to A, B here. You can have this line. You can have this line, left hand, right hand limit. You can have this line. You can have this line. Or you can have this line. Or you can have this line. So you can have infinite number of paths that we can take a move, that we can go to A, B, right? So in two variables, there are literally an infinite number of paths that we can take as we move in A, B here. So you can have this line, this line, this line, this line, this line, this line. So it can go lot of line here. So, but limit must be unique. So we're gonna use this technique to learn that if we find any two lines that the limit is not equal, that limit are different, so we're gonna conclude that the limit does not exist. So this is the idea. Limit exists. It does imply that limit, if the limit exists and equal to L, it means that the limit equal to L on every line. If you know that the limit exists and it's equal to L, so it means that limit gonna be L for every single line, right? So if you find two lines that limits are different, then the limit does not exist. So one more time, so the limit, if you find two lines that the limit are different, so the limit does not exist. Okay? Because you can pick one line here, and if the limit does not exist, so if limit they are different, so the limit does not exist, and that all you need for this the question, then you can conclude that the limit does not exist. Or even if you find one line that the limit does not exist, then it can be concluded that the limit does not exist as well. The limit does not exist as well if you find one line that the limit does not exist. Okay, so let's try to see the example here. You done? Example 5. We're gonna show that the limit of x plus 2y over x minus 2y does not exist. So we're gonna start by trying to compute the function here. So if you plug in 0 and plug in 0 here, so you're gonna get 0 plus 2 times 0 over 0 minus 2 times 0. This is actually 0 over 0. So you need to do the conjugate or factoring first, but you can see that you have no way to conjugate and you have no way to factor out. So we're gonna just trying to do the limit does not exist by picking two different lines. Choose C1 to be the line you want. So let's suppose that I know that the point that I'm taking the limit to is 0, 0, right? So I need any line that it's gonna pass 0, 0. So first of all, I can pick x equal to 0 and y equal to 0 for sure. So I'm gonna pick the line, the first one. I'm gonna pick the line from the left here. This is the line y equal to 0, right? So we're gonna pick C1, y equal to 0. Technically here, you can pick any line that passes 0, 0. You can pick any line that passes 0, 0. It will work. So you pick y equal to 0. This is the first one that I'm gonna pick. So I'm gonna have limit x, y go to 0, 0 on C1. It means I'm gonna just compute limit on the line C1 here. So I have x plus 2y over x minus 2y. So once I pick, once I say on C1, it means that I'm gonna just only consider y equal to 0. So my limit gonna be just limit x plus 2 times 0 over x minus 2 times 0. It's gonna be like this because we already know that we're gonna take a look on C1. So y is gonna be 0. And this is actually 1 because this gonna have x, this gonna have x, and x cancel x, so you're gonna get 1. So the limit on this line is 1. You can pick another line, and then if you get the different limits, it's gonna be okay. So it's gonna be the case that you can have, we're gonna that you can conclude that the limit does not exist. What are another line that you can pick? Yeah, you can pick here. Okay, so maybe you can pick y equal to x squared here. This is the line that also pass the point 0, 0. So you're gonna pick y equal to x squared. For example, so you're gonna have limit x, y go to 0, 0. But this time you do it on C2. This is plus. When you do it on C2, it's gonna be x plus 2 times x squared over x minus 2 times x squared. The top part, gonna group it up so you get 3x squared, right? The bottom part, you're gonna have minus x squared. So what is the limit here? Negative 3. We're gonna just take a look one more time. Oh, no. Yeah, you cannot. You cannot. 1 second. You cannot group it up, right? Because on the top part, you have 2x squared plus x. The bottom part, you have minus 2x squared. So you have to pull out 1x and cancel first. C. Oops. X, y. Go to 0, 0 on C2. So you pull out 1x. So you get 1 plus 2x. And you pull out 1x. You get 1 minus 2x. Okay? And your x gonna cancel one time. Chop, chop. And then you're gonna have limit 1 plus 2x over 1 minus 2x. You plug in x equal to 0, you get 1. Does it make sense? And this means this line, you pick C2, you get the same limit as C1. So this line doesn't give you anything because you have the same limit. So you have to pick another one so you get different limit. So you need to keep picking until you get the one that is different from each other, because actually what you need two lines that they are not equal to each other, like the limit they are different, so you can conclude that the limit does not exist. So the one that we choose for C2 is not good enough to conclude that the limit does not exist. What else you can choose here? X equal to 0. Some people say, why don't we choose the simple one, x equal to 0? So x equal to 0. So once you pick x equal to 0, this is much easier than the previous one because you can plug in x equal to 0. It is a good one to pick the hard line because we're gonna have to learn how to pick the hard one as well. Alright, so we're gonna just plug in x equal to 0 here. Not bad for this one. Right, not bad for this one. This one we are lucky enough that when we plug in x equal to 0, so you have 2y on the top. You have negative 2y at the bottom. No matter what y is, we're gonna just cancel y as well. So the answer gonna be 2 over negative 2, which is negative 1, right? Now you are good enough because this gonna give you different limits, 1 and negative 1. So because of these two, you can compute that you can conclude that the limit does not exist.
So how can if you didn't say that it doesn't exist, so how do I know that it really exists or not exist? Or I have to find the line and I keep finding until I find one that does not exist. What should I do?
So technically, what you're gonna do is like you're gonna start by plugging in numbers into the function first. If you can compute it and it gives you a real number, that means the limit exists equal to that number. But if you plug in and you get 0 over 0, you should try to do factoring and conjugate first. If you feel like you cannot do factoring and conjugate, you try so hard already, maybe the limit does not exist. If the limit does not exist, you can show it by picking two lines that give you different limits. But if you keep picking and you get the same thing, 1, 1, 1, 1, 1, 1, 1, maybe it's actually exists, but you just cannot prove it. So you have to go back to use the factoring and conjugate technique. Does it make sense? We can conclude that the limit does exist because limit on the line y equal to 0 is not equal to limit on the line x equal to 0. Okay, so this is the one that you can conclude that the limit does not exist here. Well, of course, there are more than one solution for this question. So if you can pick y equal to x as well. Give you if you pick y equal to x, you're gonna get the limit equal to negative 3. So it also works when you pick y equal to x. Y equal to negative x should work as well. So technically you can pick any line that pass the point 0, 0, and that would be okay. To show that the limit does not exist here. All right, example 6.
Is there a strategy to pick what I need?
Usually the line that we're gonna pick, we should start from the easy one. X equal to 0, y equal to 0, y equal to x, y equal to x squared, something. You're trying to avoid the line that is hard, something like y equal to square root x. We are not going to pick it a lot because we have square root. Or y equal to sine x, you are not going to pick this one because even it pass 0, 0, but it is super hard to simplify sine x, for example. Well, for this class, if you already pick x equal to 0, y equal to 0, x squared, y equal to x, and y equal to x to the n power, and you feel like you cannot do it anymore, so it's maybe it's gonna actually the limit exists. You have to find another way to do it.
In the question, do you tell that the limit does not
Some
exist?
questions gonna say that prove that the limit doesn't exist. Some question gonna say nothing. So you have to. It depends on question. Then you have to figure out by yourself if it's just say that evaluate the limits. So you have to figure out by yourself the limit exists or not. Like the next example, we're gonna learn how to pick the line one more line here. One more time here. Example 6. Limit x square y over x to the fourth power plus y square. Maybe this is a good one that when you finish it you can stop here because it's like 11:32 now. So we're gonna start by trying to use the technique that we learned before. So you plug in 0, you plug in 0, you plug in 0, you plug in 0. So it's actually 0 over 0, right?
Yep.
Can you factoring or conjugate?
I don't think so.
You cannot factoring and you cannot conjugate, right? Because it's like you have x to the fourth power plus y square, so no way that you gonna factoring or conjugate. So we're gonna just show that the limit doesn't exist by picking the line. So choose C1 to be one line. So which one do you prefer? Okay, let's start from the simple one, x equal to 0. So once you pick x equal to 0, then the limit x, y go to 0, 0 on C1. It's gonna be, you plug in 0. You're lucky enough that this is not 0 over 0 anymore. So it's gonna be 0 over y square, right? When you pick x equal to 0, it's actually 0 over y square. And when you compute limit 0 over y square, you're gonna get 0, right? So the first line you get limit equal to 0. So you need to find another one that the limit is not equal to 0. Which one can you pick? Okay, so the technique is that if you see x to the fourth power here, you probably need to pick something that you can balance the degree here. So if you see y square here, the good idea is you pick y equal to x squared, so you get x to the fourth power here. So you can group this thing together. So basically you're gonna pick y equal to x squared. So once you pick y equal to x squared, this line also works because it's past 0, 0. So it's gonna be limit x, y go to 0, 0 on C2, and then you're gonna just plug in y equal to x squared here. And once you simplify, you're gonna get limit x to the fourth power over x to the fourth power plus x to the fourth power, which give you a good thing because this gonna cancel and then you get 1/2. So you get 1/2 cup. So this one, once you get 1/2 and 0, so they are not equal to each other. Because limit on C1 is not the same as limit on C2. We conclude that the limit does not exist. Okay นะครับ This is the way we learn how to compute limit for the question that you need to show that the limit doesn't exist. You can do this way. So to sum up, what you learned today for the limit is that you learn that first of all, when you see limit f(x,y), so you try to plug in first. You try to plug in first. If you plug in and if you get number L, you're done. If you get 0/0, you can try to do conjugate and factoring first. If you conjugate and factoring and you can cancel something, it should be good, and then you're gonna get the number L as well. So this is done. But if it does not work, so you can go to picking two lines that give you different one. Picking two lines with different limits. And then you're gonna conclude that the limit does not exist. Okay. This is the thing that you should have in your head, that this is a flow chart that you can start by seeing the limit. You plug in number, you see if it get the number L, then you're done. 0/0, you do the conjugate and factoring. If it does not work, you're picking two lines with different limits. For Wednesday, we're gonna learn when you pick the line and then you always get the same number. Like you pick the line, you keep trying, you get 0/0/0, for example, and you get tired from picking the line. You can use a squeezing theorem to actually conclude that the answer is 0. So we're gonna have one more thing to learn, which is squeezing theorem. Squeezing theorem. This is the thing that you can do it when you feel like you are hopeless with the line, because you always pick and then limit gets 0 all the time. It means probably the limit is actually that number. So we're gonna use the squeeze theorem to help us to conclude that the limit is actually 0. Does it make sense? So this is going to be about 15 to 20% on the final. จดก่อนครับ yes. This is the last example, so we're gonna end the class in 5 minutes, but yeah, this is the last example, so you have time to read the lab in the afternoon.